Hello, my chemistry and earth systems classes. Welcome to Chemistry of the Earth, the video unit. Unit is going to be covering Unit 1, Lesson 2, the Earth-Sun relations. We're going to be working on this one a little while, and because in some of my classes I'm having a difficult time teaching, what we're going to do is we're actually going to have the teachable parts via video. You guys are going to work on the lab. And from there, if you have questions, you'll raise your hand and I'll be happy to help out. Um, that way I'm not fighting with talking over people. So the videos are going to be an important part of this lab. Now you guys will not have this on paper. What you will have is a couple of pieces of paper to help you out. There's this paper that looks like this and this paper like this that you guys will be using throughout the lab. Um, as for you guys, where are you going to put the answers to this? You are going to put the answers to this lab. You're going to go into Canvas, and in Canvas, you're going to go down to the day. Now, I don't have it posted at the time of making this video, but for you guys, it'll be Friday and Monday, and we'll be working on this for several weeks. So it'll go Friday and Monday and several days into the near future. You'll go through, you'll open it up as we usually do with assignments. This is what the assignment is going to look like. I will be adding I'll be adding the videos into it later. It's going to be really important that you go through and read these sections through here because it's going to go through and explain. I'll try to summarize them. I'll try to explain them to maybe where it makes more sense, but that is the gist of the lab. So that's going to be the part that you guys get it. The first thing that you guys are going to do is you're going to go through and do these vocabulary words. Now there's a couple of ways you could do this. You could do this on the internet. You could look up the word weather on the internet. That's pretty obvious. Do a little Google search and say, hey, what is a Langley? What is a calorie? What is a solar constant? The thing about it is calorie sometimes is referred to as something that's in food. And science is considered how much energy an object has in it. And what's going to happen on when you go to Google is it's going to probably, number one, give you the food thing. Well, this is nothing to do with food. This is about weather. So you want to make sure that when you look up the vocabularies, words of these online, you're using the ones that pertain to what we are doing. If I scroll down here, you can see within the stuff that you're supposed to read. So these are the sections right here where it says introduction. You need to be reading these. And notice words like weather, Langley, calorie are in bold. Most of these words are given to you in bold. So you can go through and watch or read what they are. For example, weather is the state of the atmosphere at a particular time, a particular place for a short period of time. I mean, I could literally, since this now is a document, I used to tell people just to copy it from word to word. Now you can just copy and paste. So you can hit copy and then go up here and hit paste. And then that question, that vocabulary word is done. Okay. So you go through, you need to read this. So just a brief summary of what this is talking about is weather. We talked about this in the slides before this, the difference between weather and climate. Weather is the state of the atmosphere at a particular time at a particular place. When I look outside today, I see that it's cold. I can see that it's overcast, but it's not raining. That's the weather for this area. What is climate? Climate usually considers a larger region area, like all of the Pacific Northwest, and what the weather is generally like. So if we wanted to talk about, hey, Seattle is generally a rainy area, and we have rainforests. So our climate is cooler temperatures and rain. Does that mean it's always going to be rainy and cool temperatures? No. I mean, we got to 110 degrees last summer. And sometimes it snows. That's weather. Climate is just like a description of what it's generally like. In the desert, it rains in the desert, but you think of the desert as being dry. That's climate. So I wanted to get into understanding what weather is so that we can get a better understanding of what climate is and how the climate is changing on the Earth. In order to do that, we need to understand how our atmosphere, how the gases in our air is so important to us and how much it affects us. And beyond the importance of the atmosphere, there's really two things that control the weather. Number one, and the most important thing that controls our weather, has nothing to do with the earth. It has everything to do with the sun. The sun is what gives us heat. Without that heat, our atmosphere won't move. So there are two major controls of the weather. Um, the first part is the intensity of the sun, how much sunlight we're getting. The second thing is the fact that the earth, as it goes around the sun, is not perfectly up and down like this. All right. The earth is actually tilted on its axis at about an angle of 23.5 degrees. So as it goes around the sun, at sometimes the sun is hitting the earth directly just below the equator, and other times it's hitting directly above. And that's what gives us a season. And that changes the first thing that we talked about, which is solar intensity. But a bigger question has to be asked as to why is it the tropics areas? Why is it we can go to places like the Bahamas and Hawaii or Mexico? Why is Mexico so hot, but Canada is so cold? Well, I have a lot of students who say, well, Mr. Lee, the reason why is that the equator is closer to the sun. Now, the problem with that is that, and I'm going to try to see, let's say that on that far wall, way over there, if that was the sun, that whole wall was the sun, the earth would be on the other side of the room and would be about the size of this marble, possibly even smaller. So what we're talking about is, if that's a bonfire, we're talking about the difference between the equator being right here and the North Pole being right here. So Mexico would be here, Canada would be here. Why is Mexico so warmer than Canada? Is it because it's closer to the sun? Is it closer to the bonfire? No, you're moving not even a millimeter here. So that's not going to be why Mexico is so much warmer than, say, Canada. So let's find out why. First of all, we have to understand, how do we measure that heat? We use something that's called the Langley, which its equivalency is to something called a calorie. Langley is just a measurement of solar energy that's coming in. And calories are really just a measurement of heat. Believe it or not, the food, when you're eating food and it says how many calories are in there, it's talking about how much stored energy is in that food. And it's that stored energy that when it gets released, it releases that energy in your body. And this is one of the reasons why your body is so warm, as a release of those calories. It's releasing energy. It's releasing part of that energy, could be heat. So we get these things, this heat, this energy. And I don't want to call it heat. We don't get heat from the sun. What we get from the sun is actually radiation. And you say, oh, Mr. Lee, radiation's bad. No, radiation's not bad. Radiation is actually important to our life. The radiation that we get from the sun, there's different types of radiation. You have like gamma radiation and x-rays and stuff like that. Yes, that couldn't be bad. But you have other forms of radiation that can't hurt you, like radio waves, TV waves. And then the most important thing that we'll talk about is things like light. Light is a form of radiation. So the energy that comes in from the sun and hits the earth, that is coming in the form of radiation energy. Now, how it hits the earth, that's going to determine what our weather's like. Does it hit the earth directly? Does it hit it at a low angle? Does it scatter? Is it blocked by clouds? Um, is it blocked by our atmosphere? Is it absorbed by clouds or the atmosphere? All of these things fit into the equation as to how much sunlight actually reaches the surface of the earth. And sunlight that reaches the surface of the earth is the most important part, because the sunlight itself does very little to heat up the atmosphere. What heats up the atmosphere? Well, when the sunlight hits the surface of the earth, you've probably had this happen before. You got out of the car on a hot summer day to go to the beach, your feet hit the ground, and then it's like, ouch, 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 ouch. The ground gets hot. And when the ground gets hot, it heats up. There's conduction of energy. The ground gets hot from that sunlight. It heats up the air around it. And hot air rises, cold air sinks, and that is the beginning of weather. But more importantly, let's get back to the lab. So with this lab, you need to make sure you read through this part. That's the part I just saw. Notice that this is figure 12.1. Now, you're not going to be able to draw on this, and it's going to ask you to draw on it with question 1. It says question 1, on figure 12.1, extend the 1 centimeter wide beam of sunlight vertically to point A on the surface, and the 1 second extend a second 1 centimeter beam beginning at the sun to the surface at point B. All right, so it's going to be kind of hard for you guys to do this and measure on the computer. So I am going to give you guys a piece of paper that actually has that picture on it. And what you're going to do in order to complete number 1, and there's going to be questions on what you did there. To complete number 1, you guys are going to use that piece of paper. I have rulers in the front of the classroom. Very simply, you are going to, this would represent 1 beam of light. You're going to draw a line that goes straight down, just like that. And for B, make sure that your line is straight with what's already started, and go straight down like that. Now, if you're a person, what's happening here is, in this case, the sun is shining straight down on you. If you're not directly under the sun, that means the sun's going to be hitting you at an angle. All right. So notice that in figure 12.1, the sun is directly overhead, striking you from a 90 degree angle. And that's what we're talking about there. So he is being hit by the sun at a 90 degree angle. It says, using a protractor, measure the angle of the surface of the beam of sunlight coming to point B. So this is a protractor. And what you're going to do with the protractor is you're just basically going to hold it up like this and tell me what angle that sunlight is. All right, simple enough. You may need to extend that line a little bit further because your protractor might be a little too large. Make sure the little crosshairs are where it intercepts the ground, and then you can see what it is. Then you're going to write that answer into the blank on the screen. All right, question number 3 says, what are the lengths of the line segments of point A to point B? So just so you guys know, we're looking right here. Question number 3. Is that on the screen? So you guys can see it. So question number 3 is right here. So I want to know how many millimeters there are in that line. So you need to get a ruler that has millimeters on it. Millimeters, these are usually the tinier numbers, millimeters. The numbers are centimeters on a ruler. The little tiny ones we learned from our measurement lab, the tiny ones are millimeters. So simply what I want you to do is look from this point to this point where that beam of light hits the ground, and I want you to measure how many millimeters it is. So there's 10 millimeters in every centimeter, so that would be 10, and that looks like about 15. Then you come over here and you see there's significantly less millimeters. So you're going to put that into your lab where question number 3 is, point A, point B, how many millimeters. Then it says that the 2 beams, A or B, which one is more spread out and covers a larger area? Okay, and it says highlight your answer. So basically what you see right here, it has a little highlighter tool. There's a little highlighter tool right there. You're going to click on that and get your yellow right here. And if you think that A covers the biggest surface, you're going to click on that. And you're going to go up here, you're going to highlight it with your mouse, and then you're going to click yellow, and that's how you're going to highlight it. Or if you think that it's B, you're going to highlight the B. So anytime you see these bold parentheses, that means I'm going to want you guys to highlight the correct answer. So which one covers the larger area on the surface of the Earth? Question number 5, how many more Langleys per minute? So Langleys is how much sun radiation is being received by a square centimeter on the surface of the Earth. In other words, if I look at where we're at point A or point B, if we were to look at just one small little section, who's getting more radiation? Is it going to be point A and point B? How do I answer that? How do I know which one it is? Well, actually, that's pretty simple for me to show you guys. I got a flashlight right here. See, there's a flashlight right here. And I'm going to shine the flashlight on my board right here. See, like that? So right now, I'm shining it directly on. And look how bright it is. All right? Now, keeping the flashlight the same distance away, I'm going to rotate it. And as I rotate it, so I'm about the same distance away, but I'm at about a 45-degree angle. Is it as bright? And the answer to that is that as the light is spread out over a greater area, it's not as bright. That's important. If it's directly on you, it's brighter. It's more intense. As I move it to an angle, it's less intense. Well, we're going to talk about that intensity a little bit more in the next video, but that should at least get you answering questions 1 through 5.